So we're starting the chapter 6.5, which is on graphing the quadratic function. We know that the basic quadratic function is f of x is equal to x squared. And what I did here was I took a couple of values, 5 values, and I made up a small table. This is 0 squared, 1 squared, negative 1 squared to give me positive 1, 1 squared to give me 1, negative 2 squared to give me 4, and 2 squared to give me 4. Plotted the points, x and y. This is 2 and 4, 1 and 1, 0 and 0, negative 1 and 1, negative 2 and 4. And I got this graph here. Now, I wanted to give you a couple of options. If you wanted to see the graph of this, go to y squared on your TI-84, type in x squared and graph it, and you will see this graph. I'm going to copy and paste this for us into the notes so you can see that you have the option of looking at it with your calculator. A few other options, you can try Desmos by typing in Desmos calculator and then putting in your function x squared and seeing your graph of it. This is a free online calculator as well. Now, let's go back to what we're talking about. So we want to go ahead and identify a few things. The lowest minimum point of the graph or highest maximum point of the graph is called the vertex, and the vertex have the coordinates h and k. Now, to see this, if I were to sketch a couple of graphs, one turned upwards, that lowest point on the graph, that bottom point, would be the vertex. And if I were to draw in a vertical line, remember the equation of a vertical line, x is equal to the h value. This is called the axis of symmetry. And this here is a minimum, right? Minimum, a low point. If the graph was turned upwards, the vertex would be at the top, the maximum. And it would still have the axis of symmetry, x is equal to h. What that axis of symmetry does is that it divides the graph into two equal a mirror image for the x values. The same number of points to the left and the same number of points to the right. As you can probably see from this graph here, where we went 2 points to the left and 2 points to the right. Now, I want to talk about transformations of the y equal to x squared function. X squared plus a lifts graph up a places or a units. X squared minus a drops the graph down to a units. So a graph of, say, y is equal to x squared minus 2 would be the original graph. Remember, the original graph was at 0, 0. And if we went up 2 places, it will be, the whole graph would be up 2 places that way. So the vertex would now be at 0 and 2. Okay? Sorry, this is plus 2. Up 2. Vertex is at 0 and 2. The axis does not change. That vertical line going through the center is x is equal to 0. So the axis is x is equal to 0. Now, if we were to drop the graph down 2 places, one second. Yes, if we were to drop the graph down, let's take a graph, say y is equal to x squared minus 3. By the way, I wanted to make sure that you could see this graph with your calculator as well. Right, if I went and I graphed x squared plus 2, I would see the graph being shifted 2 places upward on the vertex at 0 and 2. So let me just put that into the notes so you guys can look at it a little closer. If I graph y is equal to x squared minus 3, this is down 3. So the vertex is at 0 and negative 3, but the axis is still at x is equal to 0. And because all that happened to this graph was that it dropped down 3 places to 0 and negative 3. But that vertical line going through the middle is still at 0. So if I were to go back to my calculator here and just change it to negative 3, to minus 3 here, and graph it, you can see the entire graph is shifted downwards. Now, if we wanted to move this graph left or right, the rule is that this is left or right shift. If we have y is equal to x plus a squared, where the a is directly attached to the x, then shifted left a units, and y is equal to x minus a squared shifted right A units. A units, UINITS. So again, plus sign left, minus sign right. So a graph such as y is equal to x minus 4 squared will be shifted right 4. In other words, it will move from 0 to 4. And it will look like this instead. I'm going to craft this with the calculator just now because as you can tell, my images are not what I want them to be. Let's try that better. So that vertex will be at 4 and 0, and the axis of symmetry is now at x is equal to 4. So the axis changes when we move left or we move right. If I were to say, oh, by the way, we want to go ahead and put this into the calculator really quickly to make sure we can see this. So x minus 4 squared, and graph it, and we can see that the whole graph is now shifted 4 places to the right hand side. One second here. Okay, yeah, I just wanted it to point out the vertex so I have a better picture. 0 and 4. Now, if we were to say y is equal to x plus 5 squared, this is left 5. Vertex is at negative 5 and 0 because we're going left. Axis is x is equal to negative 5. So what will literally happen to this graph is that it will move to negative 5. It will go 5 places to the left. Then the axis would still be at x, the vertical line going through that middle, x is equal to 5. That would be at 5 and 0. Okay, so we're going to go ahead and get a picture of this as well. We're going to just change it to plus 5 and graph it. And then put in the value at negative 5, just so you can see that the graph shifted. Okay, now this takes it a step further. If I wanted to look at a graph, say f of x is equal to x minus 2 squared plus 5. So this is right 2 up 5. Right 2 and up 5. So if we had coordinates here, just to get a visual of what was happening, right 2 It will move from 0 to 2, and then it will go up 5 places. 1, 2, 3, 4, 5. That graph would move from 0, 0, right 2, and then up 5. So the graph would be up here instead. The vertex would be at 2 and 5. Okay? And the axis will still be going through 2. X is equal to 2. So if I were to say go y equals to x minus 2 squared plus 5 and graph it, I would see my graph all the way in the top right hand corner with the vertex being at 2 and 5. One more example like this. So y is equal to x plus 3 squared minus 2. So left 3, down 2. In other words, vertex -3 and then down 2. Axis x is equal to -3. Visually, what's happening to this graph is it shifted left 3 places to -3 and then down 2 places, like that. So that vertex is at -3 and -2. Okay, left 3 and then down 2. So the graph would go that way. Let me put a picture, calculate a picture of it in here just in case you want to look at it. X plus 3 minus 2. And it puts in the vertex for us. Capture this and put it into our notes. Now, we want to talk about just a couple other things really quickly. If I were to add a, y is equal to ax squared, where a is a constant. If a is greater than 1, graph is stretched upwards. So y is equal to 3x squared. The graph literally would be pulled upwards and become narrower, like that. That graph would be somebody stretching the graph upwards, pulling up on it, stretching it, and it becomes narrower. And you can actually see the result of that with your calculator. Let's look at, say, if I were to graph the original x squared function, it looks like this. And then if I were to graph right below that, I graphed 3x squared. You can see it becomes narrower. Graph becomes narrower. So that has the effect of simply making the graph narrower or stretching it upwards. The vertex does not change. In other words, the axis is still going to be at x is equal to 0. And if we were to say a is between 0 and 1, such as y is equal to 1 over 3 x squared, graph is compressed. In other words, the graph will become flatter. So if I went to my calculator and instead of 3, I put 1 over 3, x squared, look at what it does to the graph. It flattens it, it makes it smaller. And if I were to increase that decimal to something even smaller, 0.05 x squared, the graph would become even flatter. So it has the effect of flattening the graph, compressing it. Okay? However, it does not change the fact that the vertex is at 0, 0. Vertex still remains at 0, 0, and the axis is still at x is equal to 0. The last thing we want to speak about is the effect of reflecting the graph on the x-axis. And this is putting a negative sign in front of the graph. Means the a value is equal to -1. The graph will turn upside down. The original graph is like this. The new graph will be turned upside down this way. This is y is equal to -x squared. This is y is equal to +x squared. So I also want to see you to see that with your calculator, that I'm going to graph the original graph, which is x squared. And then I'm going to graph y is equal to -x squared. And you can see what happened to the graph. It flipped over the x-axis. Okay? That doesn't change where the vertex is. The vertex is still at 0, 0. So let's put this in our notes. And I want to show you one final example, okay? So to make some notes here, this is graph of y is equal to x squared, and this is the graph of y is equal to negative x squared. You can see it's reflected on the x-axis. The vertex is still at 0, 0, and the axis is still at x is equal to 0. So let's talk about one final thing. Suppose I've got y is equal to negative x squared plus 1. So this is reflected on the x-axis, shifted 1 up. So the graph was at 0, 0. It turned over on the x-axis, and then it went one place up. So is it the vertex is at 0 and 1, and it's turned downwards this time, like that. Vertex at 0 and 1, axis x is equal to 0. And can we see that with the calculator? Of course we can. Negative x squared plus 1 would lift our graph one place upwards from the vertex. If I were to say negative x plus or x minus 3 squared, where the whole of x minus 3 is in the parenthesis, this would be reflected on the x-axis, shifted 3 right. So 3 to the right, and reflected on the x-axis would be this way. So that vertex would have moved to 3 and 0. And the axis would be at the x value of the vertex, which is 3. So I'm going to graph that for you really quickly. Uh-oh. Did I graph the right? I'm sorry, it's a right shift. I put it at the left shift. Fix that. Minus 3, not plus 3. Minus 3. Okay, there it is. Trace this to, let's calculate a value, say at 3. And I would highlight the vertex for us, capture it, and put it into the notes. And this concludes what we need to speak about for chapter 6.5. We will continue with our last chapter soon. Take care.